The making and breaking of a chemical bond, leading to changes in the composition of the matter, is called a chemical reaction. Here's an example. We have 2 hydrogen molecules and 1 oxygen molecule as the reactants. The chemical reaction breaks the covalent bonds of both the hydrogen and oxygen molecules and reorganizes the atoms. The product of the chemical reaction is 2 molecules of water. It's an exothermic reaction when energy is released. It's an endothermic reaction when energy is absorbed. Here we see that the energy absorbed to break the reactant's bonds is less than the amount of energy released when the product's bonds are formed. So this one is an exothermic chemical reaction. Here's a chemical reaction that ionizes water via a process called dissociation. It is very important in the chemistry of life. Occasionally, a hydrogen atom's proton participating in a hydrogen bond between 2 water molecules dissociates from one of the water molecules and associates with the other. Dissociation involves breaking the covalent bond, with the shared hydrogen electron remaining in the valence shell of the oxygen atom, and the proton forming a covalent bond with the other oxygen atom. The receiving molecule is called a hydronium ion. It has an extra positive charge having received the positively charged proton. It is referred to as a hydrogen ion. The other molecule is called a hydroxide ion. It has a negative charge. This reaction works the other way as well, where the hydronium ion loses the proton back to a hydroxide ion. These ions are very reactive. They participate in ionic, covalent, and hydrogen bonds with a wide variety of other molecules. Because it works both ways, an equilibrium is established in any given volume of water. There are approximately 33.4 trillion water molecules in 1 liter of pure water. Only 1 water molecule out of every 554 million is dissociated. Yet, this small percentage for ions gives us 60,000 trillion of them in a liter. In pure water, the concentration of hydroxide ions and hydronium ions are each 10 to the minus 7. Although the concentrations of hydroxide and hydronium are equal in pure water, the presence of other substances can change that. A substance that increases the number of hydrogen ions in a solution is called an acid. Hydrochloric acid is a good example. It loses its hydrogen atom to a water molecule, adding an additional hydrogen ion to the solution. A substance that decreases the number of hydrogen ions in a solution is called a base. Ammonia is a good example. It takes a hydrogen ion out of the solution. The relative abundance of hydroxide ions defines pH values and has a dramatic influence on how molecules behave in a watery solution, including the inside of a living cell. In fact, the internal pH of most living cells must remain close to 7.2, including the synthetic living cell, JCVI, synthesis 3A. We'll study this cell a bit later.